Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. So tonight we're going to be tracking a near-Earth asteroid. Alright, I've got the telescope focused, so let me go ahead and take the Batonov mask off and slew over to the asteroid. Alright, so, in theory, we're now pointed at the area of the asteroid. Give this a 1-minute exposure. See if we see anything moving. That's way too loud. Unfortunately, ooh, there's a satellite coming. I don't know if it'll be in the field of view or not, because unfortunately, SkySafari Pro had a little oopsie when I updated it or something, and it has completely forgotten all of my presets for field of view for the telescope, so I will have to reprogram that into SkySafari Pro at some point. But right now I'm flying blind without being able to see where my field of view lines up with the stars and other passing satellites, things like that. So we'll see. I did a quick and dirty alignment tonight. Not going to be streaming super late because it's a weeknight and I've got to work tomorrow, but I do want to track this asteroid that a number of tabloids have been making some hay about. Hay! Speaking of hay, there goes a satellite. That would be Galileo 5, according to SkySafari Pro, so I think we're in the right region, judging by the satellite streak. So it's just a question of where we really are. So, like I said, quick and dirty alignment won't be perfect from image to image, but we are polar aligned. This is imaging with an 8-inch LX200 Classic with an S-Big ST2000 XCM camera and an A07 adaptive optics unit that I haven't fired up yet. But first, I just want to verify if we have the asteroid in the field of view. Now, I think we're a little bit off in pointing it wanted to put things up in the top right corner of the image earlier, so if we're not in frame, then it might just be slightly up and out of view, so we'll adjust that direction to try to fix it. And if all else fails, I can astrometrically solve the image and find out where we're really pointed. Oh, well, I saw our asteroid right here. It's definitely right in frame. In fact, it's moving pretty quick. So let's take a little image here with the autoguider and see if we got lucky. Doesn't look like, oops, I didn't want to do that. Doesn't look like we got all that lucky. There's a star or two, but it will probably require a pretty decent exposure to pick it up. Yeah, that's not great. Even at 0.6 of a second. Let's go to 0.8. We're riding close to the signal to noise ratio. That's a little better. It's better than nothing. Okay. So we'll go to 1x1 binning, and we'll do 60-second exposures. Before I fire this off, I'm going to go turn off the Christmas lights, because right now I think we're picking up some glare in the image actually from Christmas lights on the house. Okay, that should just about do it. That should just about do it. Now we've switched to color images, 1-minute exposures. And it's time to tweet out the stream. Make some noise here. See if we can get some people to show up. But it is 10 o'clock on a Thursday night, so I'm not expecting a huge crowd. But the unfortunate part of being me and having, ethics is that I'm not going to fearmonger about this asteroid, because it's a known fact that it's going to pass Earth by more than 10 times the distance to the Moon. It'll reach closest approach on December 11th. So it's not exactly a threat to hit Earth. The orbit is very, very well known. In fact, this asteroid was discovered, I think, in the 80s, wasn't it? 1982 dB, yeah. And the first observation known is from 1981. So this asteroid's been known about for a very long time, and the orbit is very well established. So there is 0% chance that it hits Earth or presents any kind of threat to Earth. Not exactly exciting news, is it? Okay, so now we've got the dark frame subtracted. So the asteroid's pretty obvious. You can see it's elongated here. All the other stars are nice little pinpoints. We've got the telescope well focused, tracking pretty well with the autoguider, and in fact, the adaptive optics unit. And you can see the asteroid's got this elongated shape as it moves during the exposure. So we'll continue to watch that as we track it here with the ALX 200. Just going to rearrange things here a little bit. Get that out of here. Okay, watch. There it goes. It's moving. So you can definitely see a lot of motion from frame to frame as this asteroid approaches Earth. It's not so much motion that I need Neo Tracker for this just yet, but if I were to continue tracking this as it approaches Earth and the apparent velocity increases as it gets closer to Earth, then yeah, it might make sense to use my Neo Tracker program to directly track on the asteroid with the motors. But for now, because it's moving slow enough that it doesn't dramatically smear all over the image in each frame, even in a 1-minute exposure, it makes more sense really to do auto-guiding on the stars and get nice, neat, tight stars in each frame. So let's see. Looks like its diameter, according to JPL, is 330 meters, roughly, give or take 15%. Rotational period of 15.1 hours. So it's a relatively, largish sort of asteroid, which is why it was discovered decades ago in the 80s, when we had much more primitive, well, I won't say much, but significantly less detection sensitivity on near-Earth asteroids like this. Certainly in the amateur space, things have dramatically changed. Amateur astronomers with digital deep space cameras like this are able to take images that rival what professional observatories could do 40 years ago. As for my deep space camera, unfortunately, I neglected to put in new desiccant and paid for it tonight. When I cooled the camera down, I was able to chill it down to negative 15 degrees, or what did I have it at, negative 10 at least, Celsius, but quickly found that the CCD was starting just gradually to frost up a bit, suggesting that humidity's starting to climb in the chamber and I don't have fresh desiccant in there. So I should really buy some new desiccant. The one I have in the closet's not quite cutting it anymore. You can nuke it in the microwave to recharge it a bit, but that's kind of delaying the inevitable. You can only do that so many times. So I don't know. I'll give it a nuke in the microwave next time and see if that helps. So unfortunately I'm having to run the camera warm at 3 degrees Celsius. However, this asteroid is pretty bright. According to SkySafari Pro, the predicted magnitude is about magnitude 13, which is easily in the realm of what this telescope can do without really having to even try. So 1 minute exposures, you can see how relatively bright the asteroid looks. That's not exactly hiding down in the noise, so it doesn't really matter for tonight that the camera's not cooled down to a really cold temperature. Stability of temperature is almost just as important, and that's the nice thing about having this camera. It's actively holding a set point so that the dark frame that it's using to subtract from these images is at the same temperature as the images themselves. And that stability is very important for correctly compensating for the noise profile of the camera, because thermal noise is a significant component. No, Future Shock, we're not going to die. It's a big, asteroid. It would be really bad news if it were going to hit Earth, but it's not going to. The orbit's extremely well known, and it showed up right where it should be. Telescope found it right away. And with the images we're collecting tonight, we can actually solve for the orbit ourselves and independently confirm whether or not it's a risk to hit Earth. In fact, if I were smart, and sometimes I am, I would fire up a telescope on the iTelescope network. So, cha-ching, a little plug for itelescope.net right now. I'm going to see if I can whip up a telescope on their network. Looks like Sighting Spring is... Oh, that's weird. Something goofy with... Oh, great. Server maintenance may temporarily disrupt making reservations. Oh, dear. Yeah, they're having server troubles right now, I think, because their global map is not reflecting the accurate time of day right now. But it does look like New Mexico is open. I don't know if there are reservations. Ooh. Yes, things are very kooky right now. So it's 8 o'clock in New Mexico. Nobody's booked the telescope for right now, according to the reservation system. Now, I don't know if their server's having trouble and if I'm about to step on someone's toes, but as far as I can tell, things are free and clear. So I'm going to take some images of Nereus here using iTelescope T11. Let's see. Going to set it to J2000 coordinates. Going to set the location. I bet, though, that Mayhill, New Mexico. Let's see. Yeah, that's what I thought. Doggone it. Okay, well, I'll use JPL. Man, unfortunately, SkySafari getting its settings all wiped out really messed me up. I think somehow the app, I think I remember having to, like, reset the app, and in doing so, it turns out I wiped out everything. All of my settings, all of my saved locations, all of that stuff. So, server location. It's going to be, what, H06, I think? Yes. Target body is going to be Nereus. Time is going to be now. And we're going to get astrometric coordinates. Hopefully the altitude is high enough in New Mexico, and the altitude of the asteroid for T11. Current time over there, well, it doesn't really matter. Universal time is what matters, so that's going to be, we are at 3? Yeah, 3:11 a.m. Universal time currently. Yeah, it ought to be high enough. Okay, so I'm going to copy the coordinates, dump that into T11. So this way I can get simultaneous observations. Let's see here. Oh, let's do Let's do 30 minutes of images. Why not? I don't know. How much? That doesn't tell me. Let's do 15 minutes. 15 minutes of images ought to do it. I don't want to spend too much now. T11 is a pricey telescope, but that ought to do it. 15. Duration 60 seconds. Oh, and let's set it for a few minutes from now, actually, because let's account for the time it's going to take to focus and get on the asteroid. So, let's say 21 after the hour. Let's plug in those coordinates. It's a little bit different. Run started successfully. Okay. That's good. Now, I have no idea what the weather's like down there, because the webcam wasn't working. They're having real serious server problems. So I'm just going to trust. I'm just going to trust that things are going okay. We'll find out. We'll see how the first image looks over there. So, what this will allow me to do is have simultaneous images from 2 locations. Wow, it looks like it's almost going to occult that star that it's approaching. If my telescope were positioned slightly differently, somewhere else on the Earth, it might actually do that. I don't know. Were there supposed to be any occultations of this asteroid? Occulting any stars? I don't know. That star might not be major enough to rank as something that was properly predicted for an occultation. I don't know. It's not gonna quite cover the star. It looks like it'll miss it just to the side. But it's close. It's real close. It's possible somewhere else in the world that's actually dead on. But you'd have to be in just the right place. Is this visible in Toledo? Well, if you had a telescope, yes. Visibility is a relative term here. This asteroid's about magnitude 13. The dimmest you can possibly see with your eye from dark skies, with dark adapted eyes, averted vision, not even looking directly at it, but using the peripheral vision, which is more sensitive to light, dim light, you can see down to a magnitude 7. And the higher the number in astronomy on the astronomical magnitude scale, the dimmer. And it's logarithmic, in fact. So magnitude 13 is much, much dimmer, many times dimmer than anything you can see by eye. To the telescope, an 8-inch telescope like this, it looks bright. Wow, that star really washes it out, though. The glare of the star actually obscures the asteroid in this image. That's cool. I like that. That's really neat. So basically, all the stars you're seeing here, all of them, are dimmer than anything you can see by eye. None of these would be visible to your eye. But as far as asteroids go, magnitude 13 is actually relatively bright for a near-Earth asteroid. Most of these guys are, something that are 10 times or less in size. Some of these things that we find these days, you could be looking at asteroids 50 meters in size, even 10 meters in size in some cases. Really small asteroids that can sneak up on Earth without being detected because they're much, much dimmer. But something this size, roughly 330 meters in size, yeah, that's easily detectable to modern telescopes, even amateur telescopes like this, even days before closest approach. So there you go, it's emerging now from the glare of that star. It's really cool. We have some interesting characters in the chat tonight. Anomalous zookeeper says that we know nothing, the world is a zoo, we're lying to each other and ourselves. Okay. Well, there's a lot I don't know, but I'm gonna press X to doubt on the whole world about to be ended by directed, controlled spoken words. But if you read the tabloids, they would have you believe that this asteroid is a real hazard that's about to potentially strike Earth, and NASA's worried about it. NASA's warning about it. No, NASA's not warning about it. There's a lot of tabloid nonsense out there right now about this asteroid in particular. The funny thing is, and maybe I shouldn't give them ideas. No, I definitely shouldn't give them ideas. But a lot of these tabloids would probably kill to have someone on staff who could do what I'm doing right now, and that is, live streaming the asteroid that they're writing all these fear-mongering pieces about, so they can fear-monger during a live stream and, get super chats and ad money going that way. I mean, they could make a killing, right? Instead, they're stuck with the usual fear-mongering articles that don't have a single real picture of the asteroid, just some artist rendition of a rock passing scarily close to Earth and not representing anything approaching reality in terms of where the asteroid is and how far it's truly going to be from Earth. Warning, objects in artist rendering may be further than they appear. I guess I think about that a lot when doing these kinds of streams, that it's fortunate that those kinds of individuals who make those stories, or the YouTube equivalents, generally don't have the equipment to do this, let alone the experience to know how to do it. And every time I say that, I fear I've given someone a bad idea of doing just that. And one day, sooner or later, it's going to happen. They're going to get some equipment and some kit and figure out how to use it to do that kind of thing on a regular basis. And then we'll have to combat that. Because like I said, we can run our own determination of the orbit right now. Well, maybe at the end of the night at least, once we've collected some good data here. Especially with data from New Mexico at the same time. In fact, let me check on that. Oh, it's not doing previews. Well, okay. It's taking images, but it's not showing me previews. I should have forced previews to be created. Alright, well, we'll see how it goes with the images. But at least I was able to plate solve, so that tells me it's able to see stars, even if I can't see the pictures that are coming in right now from New Mexico. I'll see them when it uploads them to the FTP server, and then I can download the full raw FITS files. So right now we're taking simultaneous images in New Mexico and here in Florida, and that will give us topocentric parallax. Parallax driven by the difference in the position on the Earth of the telescopes. And that provides additional data for a quick solution on the asteroid's orbit, because although you can track its position in the sky and the relative velocity, or the apparent velocity, relatively easily using astrometry, ordinarily it's that from a single telescope doesn't easily tell you the distance until you track it over a longer arc to solve for the orbit. But if you've got another observer location separated by thousands of miles, and you've got a nice baseline to work with and an asteroid that's relatively close to Earth, well, then you might actually see some topocentric parallax. And you might be able to leverage that to make a better determination on the distance of the asteroid and reduce the number of possibilities for where exactly the asteroid is in space, narrow down the exact orbit. So that'll be useful data for running a quick and dirty orbit solution completely free of any NASA data, completely independently, just as an amateur astronomer armed with a telescope in person and another telescope over the internet in New Mexico. But you think about the ability to do that today. You don't even have to actually own the telescope. You can just rent one from a service like itelescope.net and use it for good or for, ill intent as well if you were nefarious and clever. A nefarious and clever person might be able to figure out slightly different astrometry for it that would result in a solution that shows it, actually coming closer than NASA says, something like that, but still be close enough to the truth that it's not grossly out of whack with the images that they actually take, and try to present that in some fear-mongering article. I can definitely see that kind of thing being done by a number of pseudoscience type channels on YouTube or tabloids. So I'm always worried about that kind of thing eventually happening, but generally speaking, that takes a lot more effort and a lot more math than most of these charlatans are willing to muster. So to date, it has been an unrealized fear, thankfully. But the problem for them with trying to do that, or the thing that you could counter with, is something like this, where we're live streaming the asteroid. These images are live right now, and you can take these images that you're seeing on the screen. If you know how to do astrometry, you can upload it to a site like astrometry.net or run it locally on your own computer and solve for the coordinates of this asteroid right now. And you can look at the clock, you can see what time it is, and you can confirm for yourself that this is exactly where the asteroid should be at this time according to the official orbit. Or conversely, you can record the time, and you'll be a few seconds off from stream delay, but not dramatically so, maybe 30 seconds or so. And these are minute-long images anyway. So you can build that up over time and actually run your own solution for the orbit if you really wanted to. There's really so what I'm saying is there's really nothing stopping anyone from checking my work and seeing, first of all, does this line up with where the asteroid's supposed to be? And second of all, over time, what orbit would this indicate? Oh, thank you, Andrew Kroll, sorry. Andrew Kroll for $2. Best birthday present ever. Space pictures. Thanks. Happy birthday, Andrew. And we're up to the answer to life in the universe and everything on the number of viewers, according to my back end here. 42. Thank you all for joining me tonight. I know it's late, but I'm glad to be able to bring you guys these live images of asteroid Nereus as it approaches Earth. So again, if you're joining late, this asteroid is currently approaching Earth. It will reach closest approach on December 11th, at which time it will be a little bit more than 10 times the distance to the moon. Currently, let's see what the current distance is at this time. And this is, it doesn't much matter. It's still far enough from Earth that Earth's radius isn't going to be a huge component of this, but this is distance from telescope. Currently 6.2 million kilometers, which is about 0.041648 astronomical units, or about 0.35 light minutes, according to Sky Safari Pro. So let's see, we do the math on that. Where's my calculator? What did I say it was? It was 6.2 million kilometers divided by the average lunar distance of 384,400 kilometers gives us a current distance of about 16.1 times the distance to the moon. So over the next number of days until December 11th, it's going to get down to not quite half the current distance, a little bit more than half the current distance. And as it gets closer, the apparent motion in the sky will increase dramatically, and it'll move faster and faster across the night sky. But for now, we can watch it over hours of time, slowly creeping across the whole field of view of the telescope. You can see it's moved its way almost to the center of the image now. It started way up here somewhere, so it's moved a good distance since I started streaming. Do I know if it's in the ASIAIR database? I don't know. I'm not familiar with that particular database. I probably should be. Maybe I would know it based on the full name. I don't know. ASIAIR. Oh, is this a... Oh, this is a ASI program. That's why. No, I'm not familiar with their database. It might be, but I honestly don't know. I guess that's a ZWO ASI type thing. But it is in Sky Safari, I can confirm that. No, Archaic Revival, no need to run for your lives. We're all safe, at least from this asteroid. It's the ones we don't know about that we have to worry about. There are a number with a very, very low chance of hitting Earth at some point in the future. This particular one is a very well-known orbit. It's not a risk of being lost or hitting Earth. It's probably still considered a potentially hazardous asteroid, but that's a general category that just applies to an asteroid even if there are no known impact probabilities anytime in the foreseeable future. Let me look up the exact criteria. Because PHA means something very specific. Here we go. So specifically, all asteroids with a minimum orbit intersect distance, MOID, of 0.05 AU, astronomical units, or less, and an absolute magnitude of 22 or less are considered PHAs. So there you go. Let's see, what is the minimum orbit intersect distance on this one? It's Earth, MOID is 0.00, almost 0.004 astronomical units. So yeah, that's definitely within the criteria of 0.05. And the absolute magnitude is definitely brighter than 22. The absolute magnitude is 18.35. So absolute magnitude is sort of the the magnitude at a fixed reference distance from the observer and sun. It's just a way of knowing the intrinsic brightness of an object, which generally correlates with the size. But that's, of course, dependent on reflectivity and all of that. But when you just find an asteroid, when you've just found it, you don't generally know what the actual reflectivity percentage is. So we just categorize them by size using their absolute magnitude, knowing if you were at a fixed distance from it, how bright would it be. So it's funny, the PHA criteria actually does not include very small asteroids whose absolute magnitudes are dimmer than magnitude 22. Now, as I mentioned before, this asteroid's apparent magnitude is much brighter than its absolute magnitude right now. Its absolute magnitude being a little over 18, but its apparent magnitude is only about 13 because it's relatively close to Earth. It's much closer than the reference distance, as it were, which I think, off the top of my head, I think it's like 1 AU. I think it's 1 astronomical unit. But I'm just going off the top of my head there. So, yeah, it's just a criteria based on how close does its orbit get to Earth's orbit, which in this case is quite close, and is it big, or is it big enough to qualify? And it is both of those things, even though we know there's no impact probabilities anytime in the foreseeable future for hundreds of years. So it's not a concern in our lifetimes at all. But it's still called a PHA, or potentially hazardous asteroid, because it meets those two criteria. So you might think, well, those criteria aren't very meaningful then. But it's really just a broad category of asteroids that humanity should keep an eye on for generations to come. That one day, perturbations of its orbit may one day bring it into contact with Earth, millennia from now or something. But for the foreseeable future, anything that we have to worry about right now, it's not an issue. Unistellar would have mentioned if there were an occultation. Yeah, that's probably true. But some of these faint stars here, like, these little dots you see around the image, not the really colorful ones, those are residual hot pixels, but the actual stars you see, a lot of these stars would probably be so dim that they wouldn't necessarily show up on a catalog of stars that Unistellar might check, or most occultation websites or predictions would check, because in some cases those stars' own coordinates aren't necessarily nailed down precisely enough to make an accurate prediction of the occultation. So this star up here, though, that one probably is significant enough to be on someone's category, or someone's catalog, I should say. Yeah, if I rewind a little bit here. Yeah, that's definitely a star that would have been on someone's radar, because it's in the Tycho catalog 3723-0575-1. So if that occultation were occurring, then somebody would have known. It's magnitude 11, so a little bit brighter than the asteroid. Not by a huge margin, but by a little bit. Let's see. What are some asteroid occultation predictions for right now? Yeah, see, here's one with... It's not this asteroid, it's not this star, but it's a similar star, also in the Tycho catalog. Let's see. We'll just search this list and see if Nereus comes up at all. It does not. So I guess there was no predicted occultation. Yeah, this covers the whole month of December. And there's a ton of them. It's just this is not one of them. Which surprises me a little bit. I would think that parallax would allow that occultation to happen from somewhere on Earth, but maybe not. Yeah. Alright, so I got my usage receipt from iTelescope. Yeah, that set me back $52 worth of telescope time, but I'm sure it's well worth it. So I'll see later what those raw images look like. And we'll do some measurements there. Archaic Revival is really misconstruing what I'm presenting. Careful now, this is how rumors get started. I don't want to hear any rumors on Twitter tomorrow that I was being a doomsday prophet about this asteroid or something. I don't want to show up on the next Paul Begley stream. That could be, well, true. Elon Lift. December 11th, it'll only get as bright as 11th magnitude. Yeah, that's probably about right. Let me see. Ooh, looks like it goes by some galaxies on December 11th. Yeah, it's in Ursa Major on that night. Let's see. Though the altitude is quite low, at least at this time on December 11th. That can't be right. It must be a phase angle thing. Yeah, according to Skysafari's prediction may not be so accurate. It's showing like magnitude 12.8, 12.7. It's actually a little bit brighter before. It gets no brighter than about 12.6, according to Skysafari Pro. But again, that may not be entirely accurate. Parallax would provide mere fractions of a second in difference of viewpoint at that distance. Yeah. I don't know about fractions of a second. But, I mean, I'm not expecting it to be huge. Let's see here. Okay, let's freeze it in time there. Right, ascension... Okay, declination 551700.7. Let's just see what the difference is in declination. If I set my observer position, somewhere else. Current location. And then... let's go to New Mexico. So yeah, as of a few seconds ago, if I were in New Mexico, I just put down a pin in a random spot in New Mexico. Declination would have been 55 degrees, 16 minutes, 10.2 seconds, versus at the same time, but my current location, 55:17, 00.7. So more than a fraction of an arc second. It would have been a number of arc seconds different. Definitely detectable to a good enough telescope. With my scope and the big old monster T11 in New Mexico, it should definitely be possible to measure the parallax at this distance. 16 lunar distances is not that much on the scale of the solar system. You'll definitely see some parallax there. In fact, earlier I did, not tonight, but gosh, I guess about a year ago now, I did some measurements of Mars, parallax of Mars, using a telescope in New Mexico, or was it California? It was somewhere out west, plus my scope. And I could see the topocentric parallax of even the planet Mars during its apparition last year. So that is entirely doable. Yeah, so I'm going to try to keep the mouse cursor up with the asteroid there so people can see where it is. You definitely see a lot of motion from frame to frame. Yeah, Tony Dunn, you're absolutely right. Thanks for your video earlier, by the way. It was a nice little animation you showed there of the asteroid's orbit and its path through the sky. And this is what you tell people when they ask, would NASA tell us? Exactly right. Amateurs would see it too. And, you know, we're not beholden to some government agency keeping us silent or anything like that. We can measure the orbit just as well as NASA can. And, in fact, as I'm sure you know, amateur observations contribute a lot of data to the Minor Planet Center for their own determinations of the orbits of these asteroids. Amateur contributions are very important. While professional observatories may discover a lot of asteroids, follow-up observations oftentimes come from amateur sources as well. Circle the asteroid with my cursor. Well, I could put a box around it, but I have to be careful if I do that, because then it goes into subframe mode, and it'll only take a picture of just that portion of the image if I reset the imager at some point. But I don't think I'm going to reset it tonight, because I think I'm just going to be shooting this asteroid and wrapping up here pretty soon anyway, so go ahead and put a box around it. There you go. It's not exactly going to keep up with it, though. It'll get away from there. How does one get involved and learn more about this? I don't personally present at astronomy clubs. Haven't really done that. A lot of those guys in those clubs know a lot more about this kind of stuff than even I do, and I always feel like it's a learning opportunity for me when I go to club gatherings, places like Chiefland Astronomy Village. Those guys have more years of experience than I do doing deep space imaging or even minor planet tracking in some cases. So I always try to absorb their knowledge. But yeah, you can go to your local astronomy club and get involved, especially if you can find a location where national star parties tend to gather. A lot of those clubs will have a lot of members and some very experienced members as well. So another good way to get involved and just see some of the discussions that go on, both with amateurs and professionals, is to join the Minor Planet mailing list, MPML. If you sign up for the Minor Planet mailing list, you can get a daily email of messages going around about new discoveries or interesting findings, and there's a lot of knowledge you can absorb that way. But I think that some of the best knowledge you can get is just from experience of just trying it. And like I said earlier, you don't even have to own a telescope. I mean, I spent an hour setting this beast of a telescope up, and it's really on the low end of things when it comes to amateur astronomy these days for doing things like asteroid tracking. I mean, it's decent. The LX200's not bad, but it does have its limitations, and I've got it tuned up now with this adaptive optics unit that I'm pretty happy with its performance, but most guys would want something with a more serious mount on it with finer machining of the gears and precision and all that. But you don't have to spend the big bucks like that to get involved. You can rent a telescope from mytelescope.net, and then you don't even have to spend the time setting it up and taking care of it and spending the money to buy the thing. I mean, I acquired 15 minutes of images from T11 tonight. Cost about $50 worth of telescope time, but I mean, you'll pay that much for a video game, and this to me is just as entertaining, and maybe I'm just weird like that, but yeah, you can get some really high quality images. I mean, images from those telescopes, those are scopes that cost hundreds of thousands of dollars in some cases, and have incredible capabilities to really see very dim near-Earth asteroids and collect very high-resolution astrometry on them. So if you get involved with that and get some good software for doing astrometric reduction and formatting of reports, you can actually submit astrometric data to the Minor Planet Center and actually contribute to monitoring these asteroids, to tracking them, and to solving their orbits. So you can get involved without ever owning a telescope, just by renting some time on telescopes at places like New Mexico, at itelescope.net. They have observatories in New Mexico, California, Spain, Australia, all over the world, really. And so there's almost never a time of day that you can't go on there, and if the weather's clear, get some time on a telescope somewhere and do some of this kind of asteroid tracking. When was the last time I was published in a magazine? Oh gosh, that was back in the Comet ISON days when I took second place in Sky and Telescope's ISON photography contest. Won myself a little telescope. Nothing significant, but you know, it was nice to get recognition, to get that image in the magazine. That was very special for me. But that was the one and only time, really, that I got put into Sky and Telescope. One of these days, my goal is to get Sat Tracker tuned up enough that I feel confident enough to try to submit that to them for maybe a S&T test report review or something. So I'm working on that right now. I'm actually working on some advances with Sat Tracker to implement a new algorithm to do the tracking and do a better job compensating for lag in the motors and that kind of thing. So I've put together a program for simulating ISS passes so that I can train machine learning algorithm on it and simulate many runs of an ISS pass and many iterations of various people's, motor speeds, acceleration curves, and mount vibrations, things like that, to try to come up with a one-size-fits-all solution that will really work across a wide range of products. So that'll be good, I think. Maybe something a little more intelligent than what I've got right now for the code. What kind of program am I using? Ancient is the word. This is CCD Soft. This is not officially maintained software anymore. And in the past, it's an interesting little story. It's given me trouble in the past with other computers, especially when we went to Windows 10, when I had Windows 7, and Windows changed their, what do they call it, Aero interface or whatever. They had the new fancy UI for everything. This software really wasn't designed for that. It was designed for Windows XP, and started to get weird noise patterns in the camera images coming down from it when I started working with newer computers, and I thought something was going wrong with the camera. So I picked up another one of these cameras, an S-Big ST2000, and same thing, kept doing the same problem. And I was scratching my head, and I came to realize anytime I pulled up another window while CCD Soft was running, it generated noise. And the bigger and brighter the window, the more noise it generated. And it wasn't because the screen was going into the telescope or anything. I could shut the screen off, it didn't matter. It was entirely because of some sort of weird interference going on between the computer and the camera, and it seemed to get worse when other windows would come up. To this day, I don't know exactly why that happened. It's like some sort of analog noise feeding into the signal coming from the camera. I don't get it. I mean, the analog to digital conversion should be happening on the camera, and somehow this is causing noise that's getting into the image. It's just weird behavior. But long story short, with this computer, this is a newer HP gaming laptop, and for some reason it works great with this computer. Bringing up other windows doesn't seem to affect it at all. I have not seen, knock on wood, I have not seen the problem reoccur with this computer since I started using it. In the past, I had used a second computer, an older laptop, to run the camera and feed the HDMI signal into an HDMI capture card on this computer to stream it, and it was this whole daisy chain thing just so that I could avoid bringing up any other windows on the older computer so that I wouldn't create problems with the camera. Well, turns out the simple answer was stop using the old crappy pawn shop laptop that I had as a sacrificial laptop. And that was the answer. I used a cheap, very cheap secondhand laptop because you're out in the field, dues collecting on everything. I just didn't want to abuse a good machine I actually paid good money for and care about by subjecting it to the elements of doing astronomy out in the field at night. Well, doing that with a number of really poorly made and weak laptops seemed to be the source of all my trouble. The moment I start using a good machine with a nice, decent Core i5 processor and all the rest, it's fine. And yet, this camera and the software is ancient by today's standards. And it should run just fine on even low-end hardware. But whatever reason, with Windows 10, Windows 7, it really doesn't. It really wants... it seems like it wants a higher-end machine. Maybe it's something about the quality of the USB ports, something about the voltage coming from the USB port that's messed up on some of these older laptops. I don't know what it is. But whatever it is, it's not happening now, so I'm happy about that. Maybe a graphics driver usage thing? Could be. Who knows? Who knows? Cling wrap will protect the laptop. That's an interesting idea. Typically, I just lay blankets over it or towels over it or something to try to protect it, or I used to put them in plastic bins. Sometimes I'll do that if I'm out at Chiefland or something to sort of be able to clip blankets over the bin to shield the screen, because even with red filtering the screen, like, people on the field don't want you shining bright laptops even with red filters on them all over the field and blinding people. So typically I'll do a little more to encase it when it's out at Chiefland. Better power supply tech gets rid of the noise. Yeah, that could very well be, Andrew. I was kind of thinking along those lines in terms of like the voltage coming from the USB port itself might be cleaner on this laptop because it's nicer. It's just a better quality laptop. But you're probably right. There's probably a lot to it in terms of just the power supply for the laptop. This laptop's power supply is definitely, going to be a better device than some crappy thing pull off a shelf at a pawn shop. Just joined the Minor Planet mailing list. Any other resources or email subscriptions that you find useful for sharing astronomy? Great. I mean, there's quite a number of things you can get involved in. Cloudy Nights Forum, another good resource. A lot of subforums there dedicated for various types of observing that you might find interesting. Solar system observing, deep sky observing. There's specific brands subforums, so they have a subforum for celestron scopes, Meade scopes, all of that kind of stuff. Definitely look into getting involved there, and you'll find a lot of knowledgeable people who know more than I do about all of this stuff. So we're coming up on 11 o'clock here. I'm going to be wrapping it up before too long here. I got to get up early tomorrow. I'm going to have some serious work to do tomorrow, so can't stay up all night, unfortunately, for tonight, although the viewing is nice. It's a nice, clear night. Yeah, I don't get on cloudy nights as often as I should either, but yeah, Mike Wiesner's site's a great one for Meade, especially if you have an ETX. It seems like it's a real gold mine of information on the ETX brand of scopes, or ETX line of scopes, I should say. And if you want to, find a good site to pick up a used telescope, highly recommend Astronomy. They do have a paid membership. You have to do a paid membership to contact people or reply to classifieds, but it's cheap. It's I forget. It's a very minimal nominal fee just to keep their servers running, and well worth your time and money if you are in the market for used hardware. I've picked up a number of things there, both bought and sold items on Astromart, so check that out as well. I'm in Florida, over on the west coast of Florida. Gulf Coast, I should say. Actually, I saw the Starlink launch tonight from the west coast of Florida. I'm right at the edge of where realistically you could even see a launch, and I hadn't seen one from where I'm living now before now, but part of that's because I've got a fair number of trees in the east from my property. But I was at a stoplight and heard the Twitter ding, and the liftoff was occurring, and I look over to my left, and there, just at the edge of the trees, there was the first stage of the rocket. It rose out of the trees right as MECO happened on the first stage, and then I saw a second stage light up, and yeah, that was really cool to see from way over here. I mean, we're talking like 3 hours from the launch site. Yeah, thanks, Balmer. Maurus Balmer says, despite the sensationalized tabloid headlines, 4660 Nereus is going to skim by at a nice safe distance of 3.93 million kilometers, or 2.44 million miles. It sounds about right. Yeah, it's about 10 times the distance to the moon. Oh, that's cool, Sam. Yeah, I didn't get any pictures or video or anything. I was just literally at a stoplight and just saw it by eye, and that was cool for me. I mean, there's no way I was going to make it out there tonight with all the work going on right now. No, I didn't get to see the booster coming back. From where I'm at, I was lucky to even see MECO. I'm about a 3-hour drive from the Cape. Oh, yeah. So you did get to see the reentry burn. That's cool. That's neat. Yeah, STP-2. Yeah, that was the night launch of the Falcon Heavy. And that was a sight to see. I tell you what, the SpaceX Nebula, as they call it, the boost back burn of the boosters, interacting with the first stage plume, or well, not the first stage, the center core plume, as the boosters turned around to flip back and come back to the launch site. Man, that was really wild. Yeah, I didn't see the. I don't think I saw the first stage light. Maybe that's what I was seeing. I thought I saw the second stage light up, but maybe it was the first stage. Did they do a boost back burn tonight, or did they just do a reentry burn? I didn't see the webcast at all. I haven't even gone back and looked at the replay of it yet. I saw what I saw in the sky, and that's all I know. And from where I'm at, I'm so far away that even if I was seeing the first stage boost back, like, I couldn't really have told that's what it was. It's just a dot. It was just re-entry tonight? Okay, yeah. I didn't notice any kind of SpaceX nebula effect or anything in the sky, but I'm not entirely sure I even would from over here. Because, yeah, Sam knows I'm even further away from the launch site than he is. So I got a really minimalist view of it. Oh, the Starlink satellites flew by where you are? Oh, that's cool, yeah. I've only seen that just after launch once. I was visiting my brother in New Mexico at the time, and it was just after one of these Starlink launches, and I show up at his house and I tell him, come outside, because I knew it was going to pass over any minute, and sure enough, we saw it. It was fantastic, this train of satellites. Oh, hey, no, I'm not using an electric focuser. I'm just using good old manual focusing, but I am using a Batonov mask to try to tune it precisely. So you pinged me about the CPC 1100. Yeah, focusing that thing, I bet, is a beast. No, I'm not using any kind of microfocuser or anything. It'd be nice, but it's a frill I just haven't sprung for at any point. But I am looking forward to getting Sat Tracker working even better with Nexstar scopes and other ASCOM compatible scopes. So yeah, I'm really curious to see what kind of images you're able to get with the CPC 1100 with the Sat Tracker, if you get that at some point. Got some massive 20x 80mm binoculars. Probably get a nice view of SpaceX launches from my place. Yeah, that would do a trick. I do enjoy just driving over there when I can, of course. It kills me to have to be over here and see it. But, hey, I'm glad I got to see something of it, at least tonight. That was cool. Yeah, I've tried to video Starlink passes. I mean, I have. I'm most proud of getting the close-up of Starlink shortly after one of the launches, where you could see the solar array extended. It was in the open book attitude configuration where the solar array is parallel to the Earth's surface. And I got a couple of Starlink satellites at high magnification that way with the scope. That was a while ago, but yeah, the timing just has to be right for that. Best to get them within maybe 24 to 48 hours after launch. Alright, folks. Well, I'm going to be wrapping up here shortly because it's getting to be late and I need to pack it up. But we got some decent images here. Let's see, what do we have? We're working on image 59, so we'll get it up to image 60 before I turn it in. Turn that off for a second. Let's see here. Yeah, we're doing good. Yeah, my pleasure. Thanks, Tony. Glad you came by. So, folks, if you haven't already, consider subscribing, because I do like to provide live images, especially of transient events like this with asteroids and comets. I'm hoping to get some images of Comet Leonard before too long. Just gotta get the right timing on that with everything. And personally, my availability is really the issue right now. But I'm hoping sometime in the next week or so I'll squeeze it in some early morning. Some images of Comet Leonard in the early morning hours. But yeah, thanks for coming by, thanks for watching, and I'll see you guys next time. Clear skies.